Hello, my name is Thomas Wilson. I'm a part of Challenge 2014, and today in our interactive learning video, we're going to be integrating x times ln x dx. And when you're multiplying by two different types of functions, like we have a logarithmic and an algebraic function, you have to use integration by parts. And in order to use integration by parts, you have to use this formula, which you derive from using u and v. And so you get uv minus the integral of v derivative of u, and that's going to be your integration. So the first part in doing integration by parts is picking your u value. And for picking your u value, there's a simplified expression you can use. It's called Lie8. And using Lie8, it tells you the order the order you use to pick your u value. So the first thing is logarithmic functions go first, then inverse functions, then algebraic, then trigonometric, then exponential. And so if you ever have a logarithmic function in your equation, you're always going to use that as your u value, and it just goes down from there. So in the equation we have an x and a natural log of x. So the log is above x in the expression, so we're going to use that for our u value instead of x, which is algebraic. So we have our u is natural log of x, and everything that's not part of u is then set as the derivative of v. So since our x was not part of our u, we're going to set that equal to dv. And then we solve for the derivative of u, and then we solve for just v. So we integrate this and we take the derivative of this. So the derivative of ln x is 1 over x dx, and then the integration of x is x squared over 2. Okay, and then now that we have all of our values, we just plug them back into this function. So we get natural log of x times x squared divided by 2 minus I'll take that out for now, minus x squared over 2 times 1 over x dx. And since we have this x squared over 2, what I like to do is whenever I have a constant I can take out, I take it out, so I took out the 1/2 there. Then in the next thing I rewrote it, so everything's the same except I wrote this as x, and since you're gonna have, since the 2's gone, you have x squared over x, and that cancels out to just x. So that's how we got x dx here. And so now you're just going to take the integral of x dx and simplify, and you'll be done. So the integral